different languages and frameworks and servers take different approaches for how to deal with I/O and how to deal with performance. We have the Go routines, we have the Node.js NIO first approach, we have Java, which mainly focuses on multiple threads, although it also has NIO from Java 1.4, and we have the PHP and the Ruby state of mind, where it's a process-based approach at the time that it used Apache. We are going to take it as an example of a service that takes the processes approach. So what are these different approaches? One approach says that when I do an I/O request, then I go from the user space into the kernel space. When I do this, I do a system call. I basically ask the kernel or the operation system, I want some stuff from the disk, or I want some stuff from the network, please give it to me. However, because it takes much more time to take some stuff from the I/O or from the network, then the operation system will say, okay, wait, got it. I got the results from the disk and I got the results from the network, here it's back. But on this approach, we wasted a lot of time waiting for the operation system, right? Because we were just waiting. This is standard I/O, or what's called blocking I/O, where we basically wait for the operation system. We use the system calls that are waiting for the I/O to return. This is good because it's simple. You do a call, you wait for the result, you get it back. When you do x equals x plus 1, you do a call, you wait for the CPU, and you get back the result. This is the same thing with blocking I/O, where you do a call, you wait for the result, and you get back the result. The way to mitigate that is to use multiple processes. For example, in PHP or Ruby, if we take the process-based approach, which was used in the past in the Apache web server, then in this process-based approach, what we did is that we got a request from the user, we started a new process or used an existing process, and this process could wait, because if another request came along, a concurrent one, we could simply start a new process and let it handle it. And we don't care that the previous process is now waiting for 10 seconds for an I/O. We don't care, because the new user is utilizing a new request, which is utilizing a new process. So blocking I/O is good for us. It's very convenient. The Java thread model means that in most applications, it's in the blocking I/O, in most applications, you get a request, you start a new thread, not a new process, a new thread, and you do the I/O call if you need to. So while we wait for this I/O call, a new user request could come along. So we start a new thread or use an existing thread and do the I/O if we need to, and wait for it. So this is also good, because while we wait for the blocking I/O, we have different threads which are handling different requests. So everything is great. And with threads, we could also use some shared memory as opposed to processes. Good, bad, doesn't matter right now. What matters is that the blocking I/O is simple, is good for us. We wait for I/O, and we can utilize the CPU for other aims, such as handling other user requests. And then came along Node.js, the new kid in the block, and said, I will go full force on NIO, okay? I will not do any blocking I/O, I will go full force on the NIO. Java also has this with NIO. It's an old feature from Java 1.4. But Node.js took the stance, I will do only NIO. So how does it do at the NIO? It has a single thread, and then this single thread receives a request, and now you say, okay, I need to read something from disk or from the network, or write something into a database in Node.js. So I just send the request to read, it gets into a queue and of the kernel of the operation system and immediately gets back. But I didn't get back the result. This is the essence of the NIO. So I need to say, okay, when you have the result, then call me back. And this is where you start to see all the callbacks or all the syntactic sugar around the callbacks in whatever language. You use Java, Node.js, JavaScript, so you get all these callbacks because you get a request from the user, and then instead of waiting for your request that does the I/O or the network I/O to return, you just say, okay, I want to write these bytes to disk, but get back to me immediately. And when you have the results, tell me. And while you not wait, because you don't wait for the results, you got back immediately, you say, okay, and this is, by the way, this is the callback, that when you have the result, call this callback. And then on the meanwhile, you can start serving new requests because you are idle. You are just waiting for the operation system to notify you when the call to the disk has finished. So we saw these three techniques. Start a new process and wait for the I/O. Start a new thread. So everything is great. Of course, we have the context switches, but the context switches you should consider them both as advantage or disadvantage, because if you have the context switches, you also have the convenience of threads. If you don't have the context switches, you don't have the convenience of threads. Okay, so we have multiple processes while we wait for the I/O. We have multiple threads while we wait for the I/O. And we have also the Node.js and I/O, which we also have in Java, where we just say, I don't wait for the results. I want to trade off the convenience of waiting for the results and to have less threads, because I can serve other requests in the same thread, because the operation system will call me. And then Go came along, which is the new grandchild in the block. And she says, Go said, I have Go routines. And what is Go routines? You like the convenience of threads and processes. However, then you traded it off with waiting for I/O. So I will give you the convenience of threads and processes, and you would code as if you are waiting for the I/O to return. You won't have any callbacks, and Go lang behind the scenes will simulate, will handle all the trends on the background, will handle all the processes in the background, such as it's asynchronous, but I will take care of all this low-level asynchronicity and checking when the result is back and the callback. You don't need to mess with the callbacks. You write your Go routine. You think as if I'm blocking, but I will not block. I will do the scheduling and all the threads scheduling on behalf of you, and you code as if you are blocking, however you are not blocking. We are using non-blocking I/O. So we have these four approaches to handling I/O or to handle requests. One approach says, I will open a new request, call the I/O, wait for it. New request comes along, no problem, open a new process. Second approach, I will open a new thread, call the blocking I/O, wait for it. A new request comes along, no problem, handle it with a new thread. The third approach, I will take a new request, call the I/O without waiting, and I will give you a callback to call me when you finished. And on the meanwhile, a new request came along, no problem, handle it. But if the return from the non-blocking I/O comes along, the callback would be called. And the fourth approach says, I/O is great, but it's complex with callbacks and promises and whatever syntactic sugar. So I will replace this with my own scheduling of the threads. I will do an NIO. You would think you will wait for it. And there are syntactic sugars almost in every language that simulate this, but this is bundled inside the Golang. Okay, this is bundled inside the language that you would think you wait for it, but you don't wait. So it's like you get to eat the cake and leave it complete because you get the benefits of both worlds. But of course, the criticism and the benefits, people are saying, if you do a real benchmark and compare the threads with the convenience with the blocking I/O, you will see that the performance is very high. No need to take the extreme of the NIO. You lose convenience, and there are the other guys which will show you with the benchmarks that NIO is much faster, but then you say it's more complex, but then they say, yes, but we have the syntactic sugar of async await. So this is the world. I would say that if you take the standard method of multi-threads, then it could be convenient with today's computer, also fast and more simpler than taking the NIO approach, but you could choose. You could take the NIO approach and use syntactic sugar to make things simpler, or use promises or callbacks, or you could take the threads processes approach. In any way, I hope we made some organization and sorting out of the different approaches, because if you hear this one is NIO, this is IO, yes, but we have threads, we have processes, but now we know that we have these approaches: new process, new thread, block, NIO, don't block, use callbacks, or syntactic sugar, or built into the language of NIO, and you think you wait. You write your code as if you wait. So I think this was very interesting, and see you next time.